In this video, I'll be helping you with the ALEKS problem type called writing an equation of a hyperbola given the foci and the vertices. I've included a graph here because I'd like to start by graphing the information given. We have foci at 8, 2 and 12, 2. So from this piece of information alone, I can determine that our transverse axis is going to be horizontal. That means the standard form will be x minus h squared over a squared minus y minus k squared over b squared equals 1. This would give us a horizontal transverse axis because the x minus h is first. If the y minus k would have been first, we would have had a vertical transverse axis. We can also tell that the center will be exactly in the middle of these two foci, and the midpoint here is 10, 2. Knowing that our center is 10, 2, we would have x minus h is 10, so x minus 10. Our k is 2, y minus 2 is inside the second parentheses. And I'm just going to make a note that the distance from the center to the foci is c, and here that distance is 2 units. So this is 12, 2, this is 10, 2, 2 units, so c is 2. But we need to find a and b to finish our equation here, and that's where we can turn next to the vertices of 9, 2 and 11, 2. 9, 2 and 11, 2. The vertices are where the hyperbola goes through, and the distance from the center to that point going horizontally would be the variable under the x. So here that distance is 1. That means that a is 1. So a squared is 1 squared, or 1. And the last thing I need is b squared. And since we know c squared equals a squared plus b squared, we found c is 2, so c squared is 4. A is 1, so a squared is 1. Solving here for b squared, I would subtract the 1 over. 3 is equal to b squared. And b squared is actually what I need to put underneath the second fraction, b squared, not b. So b squared is 3. I will put my 3 under here, and we now have all of the parts to write the equation in standard form.